Good morning all. In this video we will discuss formation of hydrides or reactivity of group 16 elements with hydrogen. Group 16 elements are oxygen, sulfur, selenium and tellurium, and their respective hydrides are H2O, H2S, H2Se and H2Te. So out of this, H2Te is radioactive. This is radioactive, and now we will study the properties of these all. So the first property is that these all are covalent. So these are covalent hydrides. These are covalent hydrides. And then water, this is liquid in nature, and rest of this, that means H2S, H2Se, H2Te, these all are gases, and these are poisonous gases and bad smelling gases. For example, H2S, it gives the smell of rotten egg. So rotten egg smell is because of the H2S, Then now structure of these hydrides. If you look at the structure of the hydrides, you are familiar with that of water. So in case of water, what is there? Like we have bent shape where oxygen atom is at the center and two hydrogen atoms are linked in this way, and there are two lone pair of electrons. So in all these, the central atom. So in general, if I write central atom as A, so A stands for oxygen, sulfur, selenium, tellurium. So it will be in this way. The structure will be, and what will be there? The hybridization is sp3 hybridization. Shape is angular or bent shape for all these hydrides. The next property is bond angle. So bond angle, by bond angle we mean the bond angle, the angle between these bond, between this. Like if oxygen is there, H2O is there, so bond angle between HOH, and here the bond angle, if tellurium is there, so bond angle between HTEH. So this bond angle. Okay, so bond angle, the trend is that bond angle decreases down the group, and the reason is that as we move down the group, so at that time size increases. Just look here, for tellurium the size will be more, and even like these orbitals, these will be larger in size as compared to that of the oxygen. So because the size increases and electronegativity decreases, size increases down the group, and second factor is that electronegativity decreases. So what electronegativity decreases. Now what happens if electronegativity decreases? Now this is more electronegative, so what it will do, that it will the electrons of this bond pair, so of this one, so because oxygen is more electronegative, so it will attract the electrons of this bond pair toward itself. As a result, the bond pair of OH will be more closer. So this bond pair will be more closer, and when these will be closer, so what will be there? The repulsion will be more, and the size is small. The size of this one is small, so repulsion will be more. So what is the reason? That electronegativity decreases, and bond pair, so bond pair of OH is closer to oxygen, okay, than the bond pair which is present in case of tellurium. As a result, force. So therefore, force of repulsion between bonded pair. So bonded pair of electrons. Which is the bonded pair of electrons? This one and this one. So the force of repulsion between this is more. Okay, and because of this, what will be there? That the angle will be more in case of water as compared to the rest of the elements. So angle, bond angle is more in water as compared to other. The second property which we will discuss here is physical state. So then physical state and H, that means hydrogen bonding order. Okay, so just look at water, H2O, hydrides, all the hydrides, H2S, H2SE and H2TE. So in case of water, what will be there? What is water? It is nothing but it is hydride of oxygen, and we drink it, hydride of oxygen. So H2O is hydride of oxygen. Okay, so this is liquid, and rest are gases. As I already told you, this is liquid and rest of these are gases. The reason is, in case of H2O, there is hydrogen bonding, H bonding is there. Okay, and because of H bonding, this exists as a liquid. Now for the H bonding order, what type of order is there for H bonding? So H bonding will be, in the order will be H2O, H2S, H2SC and H2TE. So the order of hydrogen bonding will be in this way. It will decrease in this way. This is order of H bonding, and reason is, if you remember, like in case of hydrogen bonding, it will exist only in those species where you have electronegative element, like you have there nitrogen is there, or oxygen is there, or fluorine are there. So these are electronegative. So in case of fluorine, because fluorine is the most electronegative element present in the periodic table, so in case of hydrogen, hydrogen bonding will be more if the central metal atom is fluorine. So it exists either with nitrogen, oxygen and fluorine. So water is, like in this case, water is having the hydrogen bonding. In rest of the element, there is weak van der Waals forces of interaction, and the van der Waals forces of interaction are present in rest of the elements. So the next property is the order of van der Waals forces. Okay, so the sixth property is van der Waals force order. So the order is for H2O, H2S, H2SC and H2TE. The order is in this way. That means the van der Waals forces increases in this way as we move down the group. The reason is that van der Waals forces they depend upon the molecular mass. So van der Waals forces, these are directly proportional to the molecular size and mass. So as we move down the group, the size increases as well as mass increases. Therefore van der Waals forces increases as we move down. The next property is acidic character. So these hydrides, these are weakly acidic, they give H positive and they give 2 H positive ions, so they behave as diprotic, 2 H positive, so they behave as a diprotic acid. If you look at H2S, so H2S will dissociate to give H positive and HS negative. This is HS negative, okay, which further dissociate to give H positive and sulfide ion S2 negative. Okay, so the hydride, the acidic character, like it increases as we move down the group in this hydride. So, and the reason is, like, as we move down the group, so acidic character increases. So for here we have to look like which can easily give hydrogen here. So as we move down the group, what is there? Size increases. So size increases as we move down the group. And what happened, that the distance between, because the size increases, this is oxygen, this is sulfur, selenium and tellurium. So as the size increases, as we move down the group, so what happens, that there is increase in bond length. So bond length, that means the bond length between this, because hydrogen, the size of hydrogen will remain same everywhere, but that of the central atom, that is increasing. So what happened, that this bond length will increase, and because this bond length increases, so bond length increases, therefore bond dissociation enthalpy decreases. That means the energy required to break the bond, that decreases. So this will easily give the H positive ion, and therefore this will be more acidic as compared to the other members of the group 16, and acidic character increases as we move down the group. The next property is thermal stability. So the thermal stability, what do we mean by thermal stability? Thermal stability means that if you are applying heat energy to some to this hydride, so which of the hydride will break easily and is unstable. Okay, so as we move down the group, so what happened, that thermal stability decreases in this way, and the reason is that as we move down the group, size increases. So the size is more, and bond length also increases, and bond dissociation enthalpy decreases. Okay, so these all factors, like the size increases, bond length increases, bond dissociation enthalpy decreases. As a result, what happened, that this thermal, because bond dissociation enthalpy decreases, that means you can easily break the bond here. Okay, and if you easily break the bond, that means this is unstable, or the thermal stability is less in this case. So as we move down the group, the thermal stability decreases. The next property is reducing character. Reducing character increases as we move down the group in this way. So first try to understand what is the reducing character. Reducing character means which can cause reduction of other species. Okay, that means addition of hydrogen to other species take place easily. So the one which gives the hydrogen very easily, so that will cause reduction of other species easily. So in this case, what happens, like all the hydride except water, are reducing in nature, and the reducing power increases down the group. And the reason is that as we move down the group, the thermal stability decreases, because this hydride is unstable. It will easily give the H positive, so it will easily give the hydrogen to other species, and therefore it is the reducing character increases for this one, and this is highly reducing in nature.